So this is some stuff that started with a chap in our group, Alex Young, did his PhD project trying to come up with a nice way to do motion capture with some wireless sensor devices, and this is a descendant of that system where I've done the hardware and firmware, and him and various other people have worked on the software, and it's shiny. You'll get to play with it. I'll tell you a bit about how it works and a few of the things we're planning to do with it. Okay, so motion capture. Most of the way of how it's done these days at the moment is you take a very big room, you put lots of very expensive infrared high frame rate cameras around it, you take everything reflective out of the room. This is an absolute pain in the ass to do. And then you put a very small number of reflective things on the thing you want to track in a manner something like this. The head's cut off. This is a breakdance actually we did some work with a couple of years ago. I'll show you some more stuff from that project a bit later. But so he's wearing a bunch of these markers. You run these cameras, you see a bunch of dots move around. And if you've got everything set up right, all you see on the images from the cameras is the dots. And then you run some software that knows where the cameras were and where they were pointing, and it tries and figure out where all these markers were. And you don't know which marker's which, and as soon as he moves his hand in front of one of them, you've lost track of which is which. So having spent some time capturing all this stuff, you then spend weeks or months afterwards manually joining up the traces and figuring out what was what. This is not something that gets you results in real time. There's systems with active markers that are better but more expensive. All this stuff is all very expensive, it takes a long time, it's a pain. So we're working on just trying to come up with something that's better, easier to use for various applications. So the way we do it is completely different. We have a lot of these. So one of these has some sensors. These three blobs here are gyroscopes, MEMS things with a vibrating tuning forks type thing in there, and you do some Coriolis effect stuff and you figure out what weight it's rotating. We've got a 3-axis accelerometer in there, same thing you've got in your Wii controller. And no, it's not my battery, it's these batteries. And we've got some magnetometers. So we know, each one of these knows where north is, which I think is somewhere over there today, where down is, as long as they're not moving around too much, so you've got all this other acceleration going on, and we know how they're rotating, and we throw all this into some maths that Alex came up with, and out comes the answer. And we do the maths on here, which is part of the clever bit of it. And so each one winds up just transmitting a little packet that says, this is my orientation. And we then take those orientations, we apply them to different bits of this very simple rigid body model of a human, and if the lengths are right, that tells us where everything is. That's about it. In terms of a simple explanation of what it does and how it works. And there's a whole lot of things we're going to use this for. So, actually, although the ones people are probably familiar with are sort of games, animation, stuff like that, an awful lot of the applications of motion capture at the moment are in healthcare. So you've got things like gait analysis labs where people have various problems walking, come in, they suit them up in one of those things with the markers and walk across, that much floor. They've got a reasonably sized lab, and you've got your cameras, and the only part of the room that all the cameras can see is about that much. So you can do some stuff, you can figure out what's happening when they're walking, you can look at how that develops over time as they learn to improve, they recover from injuries, that sort of thing, but it's very limited. What we can do with this, so all that's needed for this to work, these are doing all the work. This is parallel processing effectively. The data's coming on here, we process on here, so we limit the absolute, we transmit the bare minimum, just the orientation information, back to a radio that's currently attached to my laptop, but you can attach that to a VDA, which means you can put the whole thing in your pocket, walk out of the room, down the street, and track it as long as you like. No one else can do that right now. So we hope this is going to blow a few things out of the water. As someone has already asked, yes, we are going to do Second Life. We talked to them in the labs about that. And yeah, so if anyone wants to play with it, just come up here and I will suit you up.